Hi, this is Professor Fernandez, and this is video 1 from lesson 21. You might notice it's actually video 1A. That's because I've kind of split the topic of this video, which is just a review of trigonometry, into two videos. We'll do a video 1B as the follow-up video. So I want to just review trigonometry here for you, starting from the almost basics with this example, B.13 from Calculus Simplified. I've put in some additional information over here on the bottom, so I just want to go through that really quickly because we'll use it for this example. So we're talking here really about central angles and arc length and circumference and things like that. So to review this, suppose I have a circle and I have theta as a central angle here. So this is an angle that's going from the center of the circle measured with respect to the horizontal axis. So that's an angle theta. So that angle theta, as I sweep out its boundaries over here and over here, slices out a particular fraction of the entire circle, right? That fraction of length is what we call the arc length, and I've denoted that length by S. To figure out how much that arc length is, to measure it, right, we can do a little ratio over here. So I can do a fraction. I can say that particular snippet of arc length divided by the total arc length of the whole circle, right? The total length of the circle around, which is the circumference, that's 2 pi r, is equal to, and now I'm going to compare angles, right? Whatever this central angle theta measure is, divided by, if I went all the way around the circle, in radians, which is the degree we use to measure angles in calculus, that is 2 pi radians, right? If we used degrees to measure angles, we would say 360 degrees. Okay, so if I set up this proportion over here, if I set up this proportion over here, then I can solve for S in terms of theta and R. You can see that the 2 pi's cancel out. I would multiply both sides by R, and that gets me down here. So in other words, if you have a central angle theta in a circle, then the portion of the circumference that it traces out in terms of the arc length, S, is equal to that central angle theta times the radius R. This should kind of make sense. You know, if I draw a small circle, very small radius, and I use the same central angle, let's say 30 degrees, then this length, this S, is really tiny. If I have a much larger circle, bigger radius, but I still use the same 30-degree angle, then you can just see it that this length S is much longer than this one over here. So it makes sense that S should scale up as the radius increases, even if I keep the theta the same. Okay, so S equals R theta. So that is what we are going to be using mostly to solve this example. Let's see what the example says. Okay, consider a circle of radius 4. Great, so R equals 4. I'm going to write down here the information. Find the arc length, so find S. Find S. Subtended by the central angle theta is 45 degrees. Okay, so we're going to have to convert that into radians, right? And that'll give me a chance to show you how to do that conversion also. And then what fraction of the circle circumference is your answer? Okay, this is the second question. This is the first question. Okay, so let's treat the first question first. So find S. I'm given R and I'm given theta, but in degrees. I have to convert this to radians. So how do I convert that to radians? Well, 360 degrees is 2 pi radians. Okay, so if I divide both sides by 2, I get 180 degrees is pi radians. Awesome. So if I have 45 degrees and I want to convert it over to radians, then I do some dimensional analysis here. Pi radians is 180 degrees. Okay, and then I would multiply these out. So 45 into 180 gives me 4. Okay, and then so I get pi over 4 radians. Okay, so you might be wondering, why did I multiply by pi over 180, not by 180 over pi? So let's just talk about why that would not have worked out really quickly. If I multiply by 180 degrees over pi, radians goes in the denominator, then what happens? My units don't work out to be the right thing. First of all, I would have 45 times 180 degrees squared, right? That's even weird to write because this, multiplies that, so I get twice of it, divided by pi radians. So the units are all messed up. The radians are in the denominator. I have degrees squared in the numerator. So, this is pi, degrees squared over radian. This is a really, really crazy unit. I've never heard of it actually. So that would just be the math telling you, what, this is probably not the right conversion. So even if you did not remember how to convert this, right, you would probably go to this version anyway after running into that really weird unit. So if I do it this way, then the degrees upstairs cancel with the degrees downstairs. Just like, if I had 2 times 1/2, the 2's would cancel. Same thing, units cancel also. And the leftover unit is radian, which is what we want. So going back up here, we have found out that theta is pi over 4 radians. Right? So then I can erase all of this and continue with the solution. And I can say, okay, using all this information, and S equals R theta, then S equals R, in this case, which is 4, times the angle measure in radians, pi over 4. So these 4's cancel, and I get S equals, pi radians. Okay, again, so to reiterate in English, when you are going to use this formula for the arc length subtended by a central angle, you want to make sure that theta is in radians, not degrees, right? You will get something different, which is not really going to measure the correct arc length. If you took a piece of string, you rolled it into a circle, and you measured it, and you measured the radius in the same units, inches, it requires theta to be in radians. If you use it in degrees, your measurements would just not work out. Okay, so number 2, what's the second part of this problem? What fraction of the circle's circumference is your answer? Well, so just parsing this question, we need the circle's circumference to then figure out what fraction of that circumference is our answer, is pi. So circumference of a circle of radius r, we kind of talked about that at the beginning of the video, is 2c equals 2 pi r. Okay, so for this circle, we know that the radius is 4, so the circumference is 2 pi times 4, so that's 8 pi. Awesome. And then what fraction of that circumference is your answer? Well, our answer is pi. So we're going to do pi divided by 8 pi, which is 1 over 8. And that is 0.125, or in percentage, 12.5%. In other words, right, and pi over 4 is 45 degrees, so it's almost actually what I've drawn down here. So if I draw a circle with, it's really weird, it doesn't let me erase that. If I draw a circle where the angle is 45 degrees, there we go, pi over 4. Then when I look at the arc length subtended by that angle, which we know is now pi radians, it is 1/8 of the entire circumference. And you can kind of see how that visually makes sense here, right? This is pi. This over here would add another pi. That's 2, and then 3, 4, 5, 6. Oops, I must have messed up somewhere. So I'm dividing the circle into, let's see. Oh yeah, I messed up down there. All right, dividing the circle into quarters. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. There we go. So visually, it also works out, even if we didn't quite realize that we could do the problem this way. But again, it's 12.5% of the circle's circumference. Okay, so zooming out, and just a few quick things, as I usually do at the end of these videos to remind you of. First of all, central angle theta in radians, you know the radius, then you know what the arc length subtended is. S equals r theta. Requires theta to be in radians, so make sure you can convert, as we did over here, between degrees and radians if needed. Second thing is circumference of a circle, right? 2 pi r. 2 pi times the radius r. And circumference really is an arc length. It is just the arc length subtended by the entire angle, right? So if we start here and we let theta be 2 pi, what do we get? We get 2 pi r. That's still an s, but is a very specific s. It is the entire way around the circle, called the circumference. So in a sense, right, and that's the point, S equals r theta is a pretty fundamental relationship between the arc length around a circle or around a part of the circle and its relationship to the radius of the circle and the angle theta, the central angle. Great, thanks for watching.